ladies and gentlemen. My name is Chen. I come from Taiwan, University of Kaohsiung. It is my great pleasure to stand here today and to exchange with you my personal views. My topic is architectural practice and the sustainability of wood culture, and I will compare cases in Europe and Taiwan. This might be a strange topic because wood culture, wood structures development in Europe and Taiwan seems to be not comparable. But I touch upon this topic because of my personal experiences, because I've been in Europe for 12 years experiencing and studying wood culture. It is the 7th year since I came back to Taiwan, and in these 7 years I'm doing study on Taiwan wood culture. That's why I bring up this topic. First, some of the background information. We see more and more talks about global warming, sustainable development, and so on, which promotes a wood culture. And secondly, I will talk about the same topic in Taiwan. Next, some of the plans and the follow-up actions, and finally a conclusion. From yesterday till today, many of the senior speakers have given us very in-depth analysis on the functions and the significance of the promotion of wood culture, including the impact on and the benefits for environmental protection and urban landscaping enhancement, and also the hot island effect in urban areas. You may find in metropolis with a higher density of population, you may find very different temperature in the center, in the core of the city, and in the outskirts of the city. And because of the utilization of wood and concrete and other heat absorptive materials, there will be higher temperature in this densely built area. And then we are exposed to the question whether the traditional way of building and structure have brought us with very negative impact and biological damage. But the question is a multifaceted one. A structure has certain diversified aspects.
So in Taiwan, about 95% of the buildings are made of concrete, so it is very normal, like the previous speaker said. The next thing I want to talk about is the culture of the building. And a lot of presenters have said that of all the ethnic groups in the world, they all have the wood culture. In the morning, we heard the presentation from Japan, and also in the culture in China, and they also have the culture of wood and all the culture of wood buildings. Now they have lost the wood culture has disappeared gradually. That's the problem. Okay, next I want to talk about the recovery of European wood structure, where we talk about the continued tradition, engineered development, long-span structures, and the capacity of wood construction. And I will a huge bunch of the projects come from Ultrasonic, my teacher in Europe. Maybe some of you can know him. He was supposed to come here, but he is not available. So I just come here on his behalf to talk to you. If you have the chance to go to Europe for travel, there are a lot of ancient wood buildings remain there. You can see the photos in the left. This is a building combining the wood and the concrete, about 4 to 5 stores in the city or in the countryside, especially in the western, the central Europe. There are a lot of old village consisting only the wood structures. The whole village has been maintained and protected, so we can see there's a strong tradition in the terms of wood culture in Europe. Let's look at the photo on the right. This photo is It's Apple's Mountain in the Swiss. It's a typical multi-level farmer's house. It only has a history of 200 years. Why I said it's young because if you have chance to go to Europe, it's very easy for you to live in in a building of 200, 300 years. Why they were using the wood to build the structure? Because first there are materials around, and the second is that wood is very important. It's very good to discharge the heat, and the place is very cold, so wood will be very good to keep warm. Okay, the next project on the left is in Sweden. It looks like a very modern structure, but our investigation shows that it is a building of 15th century, about 400 or 500 years ago. The builder is unclear. It's only a village cottage. It also uses a lot of wood and a very high percentage of wood. And in Europe, North Europe is a place with abundant forest resources. This is a church left from the 16th century. UNESCO has also awarded the protection, grant protection to these churches. These are very old buildings. Okay, from the perspective of modern wood structure Europe, we can draw a conclusion on the following points. First is the large size. Because the development of modern technology, we are be able to build some large size with large span buildings using the wood. This is in-room internal sports venue in Germany. Let's look at the photo in the left. It's not from Europe. It's from United States. It was built about 20 years ago. It's a very famous building. Okay, that's the long span wood structure in Olympic. There are a lot of Olympic stadiums building upon the wood. Okay, we can see. Let's now have mentioned with the development of technology for the engineers and the architects, they can use the modern technology and the modern method to build a modern architecture. That's a very big breakthrough in recent times. Another thing is a high capacity structure using the laminated wood, especially when there's a very big span. Let's look at the left photo. Is in the southwest part of the Swiss. In winter there's a very huge rainfall in Swiss. For every meter, they can hold 1,000 tons of snow. They didn't use any steel or concrete, only wood. So that is a very big breakthrough. It's the forest around, so they can use a lot of wood. Okay, the left photo is from the France. In the center of France is an indoor swimming pool. And in Europe, a lot of wood structure has been used to replace the concrete because that is more human. That is very comfortable for human. Okay, this is a very famous structure in 1980s of Vienna. It is a long span shell structure. The span is over 100. Meters. The wood has been used to build the bridges. For example, look at the right photos. This bridge is made of solid wood. And the left, you can look to the left, up left one. These trees have the one similarities, which is can be seen in a lot of European bridges. That is, we need to have a roof over the bridges. That is one similarity of nearly all the wooden bridge on in Europe. They want to have a roof there because they want to protect the wood bridge under it. Otherwise, the durability of the wood bridge will be damaged. So the architect and designer believe that if we can have a roof building there, the lifespan or life circle of the wood bridge will be prolonged. Okay, this is a long span structure using wood trees, and that is a triangle shape in the right front upright. The people doing sports there can have a very comfortable feeling. Look at the left one. This is a very long span wooden bridge. They use polywood to build. You see that when the bridge started to work, they have a lot of farmers driving their agricultural vehicles to ride along to have the people have more confidence in the bridge. In terms of the engineering, about 15 years ago, in Lausanne, Swiss, we have done a lot of a hybrid system. You can the first system, that is the combination of wood and concrete. This concept is very simple. You know, in RC, in a lot of the at the bottom they will use a lot of steels. You know, like the professor said, to make the steel we need to use a lot of energy. So we replace the steel with wood. We just put the nail and to fix the wood on the concrete. Let's look at this profile. It's then if we replace the iron with the wood, then we can reduce a lot of carbon dioxide emission. And if we use this technology, 40 to 50% of the weight can be saved. That's a very special combined material. Okay, the same technology has been applied in many other fields. We use the log because the log is very good. We don't need to process them a lot, so a lot of energy can be saved. And the log can be very useful to support heavy weight. There's another hybrid system, like look at the picture. It's 3 to 4 tiers of buildings. In Europe, there are a lot of work using this technology. There are maybe 20 buildings using this technology. And this is another school building. Now in Europe, there's a trend or tendency saying that in school and in hospitals, the wood structure is very popular, and the government also gives subsidies to the school building and hospital buildings. If you want to build the wood structure, then that means that is very good for human health, for the environment, and the government will subsidize this practice. This is another combined structure. Okay, this maybe the largest scale is 9 buildings in Swiss. It's a 5-store building, all made of wood. This is a school building. You can see that at the basis, where there is a high demand on firefighting, we will use the traditional RC. The second, third, and the fourth floors, if they are the classroom or student attainment space or laboratories, we use only the wood. Okay, another hybrid system. We use wood and glass and combine them together. In building, glass is only something for decoration, but in modern steel structure, they develop the glass and use glass as a kind of building materials. And then we combine the glass with the wood. Here we use a wood frame and to have a polywood, and then as a result we have a wood glass beam. After the test, we see that it is a very powerful and stressful. It is very easy for extension. That's a very good technology or very new know-how, and we have used this technology to build a lot of new products. So you can see from this building, the glass is not for decoration. It's only it's a part of the structure as a beam. There's a lot of such case in Europe. Okay, the third hybrid is the stove, the wood sawdust. When the more you process the wood, the more expensive the wood will be, because the more you process the wood, then its competitiveness over against the other material will be lowered. For example, if we can use wood sawdust as the raw materials, for example, we can use the sawdust as the material of concrete. You know, the sand and the stone are not renewable. And lately in Taiwan, there's a supply gap, in supply demand gap in sand and stone. Usually we import from China mainland, but now China has banned export, somehow banned export. So we lack the sand and the stones. If we use the sawdust to replace the sand and stone to make concrete, that will be very good, and the price will be lowered. We also have the wood-sourced concrete bamboo hybrid system. In Europe, we have very special. You know, in Europe we do not have the bamboo, but in Taiwan, I know, and in southwest of China mainland, there's very big resources of bamboo. So that is a structure of bamboo and wood. The last one is the fiberglass and the wood. The combination of the wood and the fiberglass. You can see that this wall usually the fiber of the wood is the most complicated problem. If we can have the wood and the fiberglass combined together, we can have a very strong strength and very powerful structure, and then they will be more safe to use this product. This is a case of wood fiberglass. We have been using this technology to build a lot of some bridges in Swiss. We have hide the fiberglass in it because they are not very good at finding the sunshine. So this product is very good. That's the fourth use. The fifth use is now it's still under progress. I don't know whether there's the same study in China, in China mainland. It is the ultrasonic wood welding technology. We do not know polywood. We will have the friction of the wood, and what we call the welding wood. You know, we can welding the irons. Now we are trying to welding the wood. We have the two wood to got the friction between them, and then to have the fibers of the two wood to get together. Now our testing shows that after the friction, maybe 90% will be attained without any polywood. That's a very good direction. Okay, about the Europe, I want to talk some about natural resources, the simple technology. Now, we are not talking about polywood beam because that need a big investment and input and much more expensive. For example, this workshop with natural material and simple technology, we can also have a long span strong beam. Uh, we have done some.
We have done a lot of computer simulation, very good property proved. So it's at the width 20 to 25 meters, or as wide as 40, and the same craftsmanship is used. The processing technology is used, and only board is used. This is another example in France. And very simple processing technology is used. This has the largest width, over 80 meters. And the cost per unit is quite limited, it's quite low, and log is widely used. For a long time, and the cost of log is much lower than some of the processed materials. Our suggestion is that we directly use log, but there are two questions. One is the drying technique, and the other is after dry, there might be some damages to the original property of the wood of log. And in the current, generally speaking, the current processing technology is to do the drill at the core and single core drilling. And Professor Wang has just pointed out that in Europe there are these kind of practices that log is directly used as the final material for the structure. This is a picture taken in the rural areas of Switzerland. And log directly made into a bridge. Local government can afford the bill. Highway which links Switzerland to the border of France. A wooden bridge, because the local government ran out of money. And the story was like this, that the designer asked the local government, "What is your budget?" And the local government answer is that we don't have any budget, we only have wood. That's where this wooden bridge came from and was born 10 years ago. I will be briefer. These are recent works in the French-speaking area in Switzerland. Over 40 meters high. Log, board are used, and also this is a watching tower. A completely new project. This work was exhibited 10 years ago in Switzerland. And the requirement is that in the future every component can be taken apart, and the recovery rate must be calculated. And after the exhibition is over, 90% of the material used in the exhibition was sold to Rome. So economically very ideal. Actually, the processing technology for log is rather mature. Now this is also a public area being built by log in Deutschland. And the standing, and the ceiling structure are made of log. In 1999, there in Hanover, there was a very big World Expo, and the designing of the expo station put forward several principles. And if you read through these principles, you find no single word mentioning that wood must be used, but actually the structure, 90% of the structure was using wood, which has catered to today's bio requirement and was really a pioneering structure. And this is a well-known big umbrella structure in Hanover. This is the central part. I have spent a lot of time in doing the cases study, and please allow me to do a little advertisement. Now, this is a master program in Vienna, University of Vienna. This program has started, however, the enrollment rate is very low this year because whenever students think that only Deutsch, only German is used as the teaching language, so many students are reluctant to come. But this is a very good course. It talks about urban wood structure, and anyone majored in wood structural civil engineering can participate. It's a multidisciplinary program. It is also a multinational program. It will have rotatory courses in 3 countries. In Dresden, in the east of Deutschland and province Halle. Well, in these areas, the wood material and the structure technologies will be taught, and later it will be transferred to the Reno in Italy about wood recovery, the maintenance of architecture, all ancient. And later it will go to Vienna, go back to Austrian Vienna. If young friends here are interested, contact me. Professor Wang has also talked a lot about Taiwan's policy, green policy, and green structures. Among the 9 indices, most of the indices touch upon wood and timber. About 2 years ago, we started with the study on green building material and the 4 directions: health, biology, and recovery, renewable, and in this index, in these requirements, if it's an imported product, we need FSC and PFCO certification. About the future trend, I think first we have several classes like in temple and the residential areas. Wood is used. For example, this is building that was built in the Qing dynasty in Qianlong Emperor's reign. And this structure is being renovated now. And the major problem for the maintenance and renovation of ancient buildings is the inadequacy of high-quality wood. For example, the material used in that old ancient building cannot be found today. And this is Daoism structure in the middle part of Taiwan, about 220 years old. Another headache is that we don't have enough investment in material science. For example, in China, the most difficult temples to be renovated and maintained are those made of wood, because there are so many carvings, paintings, and handwriting on the wood. So it is not a single problem of making the wood strong enough to support the structure. More importantly, you must protect those precious carvings and left over on the wood. On the left, it is in the middle, it is a village. And the owner of this village or this structure is well known for his efforts in cracking down the Taiping Tianguo gangsters. And this is also found in Zhanghua, mid part of Taiwan, an ancient city. We have renovated the area. And this is in the Donggang port of Taiwan. From when the Japanese was occupying the island. It's about 30 meters wide, but we cannot retrieve the exact time when this was built. Actually, the designer later went to Japan to ask when this structure was built. However, the Japanese answer is that it was built during the war era, so it was military confidence. So nobody knows when this area was first built. Now it is not opened to the public, but we are preparing to do that. We have been doing some study on the possible renovation of these ancient buildings. We have also done some experiments, conventional methods to do these experiments. For the current wood structure, it is fair to say that Taiwan is only fledgling in building its wood structure. And the log system is one part of the three most popular types of structures and most widely used in small residential houses. In 1999, after the September 21st earthquake, many of the houses were collapsed. And in some remote areas, in mountainous areas, where the area was struck by the earthquake, people began to use biomaterials.
So this is a case they built the elementary school using the wood. This is another using the log to build a bank. That is I think Mr. Wang is more familiar with this project. This is Taipei City Library. This is a building built by both wood and steel. And this is in Nantou. This is a museum of forest industry built in laminated wood and steel system. We built a new building to protect the old structures under it. The design is made by both is the cooperation between Taiwan and Japan. In the end, I want to talk about how we promote this wood structure in Taiwan, how to enhance people's awareness. I have this following ideas. First, we want to have a development center. The second, we want to have this promoted in the schools. I will not talk about the background again. Taiwan's carbon dioxide emission is the 22 in the whole world. The 1% of the carbon dioxide globally is from Taiwan, but Taiwan's forest coverage is 58%. But with such a high rate, people cannot get a feeling. So what we need to do is first, the government should talk about it, should make some policies. And like other countries talk about the trade of carbon storage and whether Taiwan should learn from the Europe and Japan to expand the plant sustainable France to increase the carbon storage. That's a very good idea. So we established a wood structure research center in Kaohsiung University to get together all these different ideas to have a comprehensive consideration in terms of sustainable forests, renewable architect, and other technology. That's our initial ideas. So last year we held international forum to talk about the wood structure, the advanced technology, and the designing application. This is the case of the last year. That's the first action. Second action, we want to build a wooden building on campus. to give a demonstration about we will use a lot of advanced technology in this building. This is the space simulation, and we will start actual building next month. This of course, it's a wood building with long spans. We will use energy saving method. So our goals of the project is to introduce more engineered wood into the public construction, to demonstrate the feasibility of developing large span wood structure to integrate the woods. Okay, our last goal is to build a exhibition. That's our big idea. That is to hold the exhibition for wood culture, to understand the wood structure, to understand its structure, to have a correct wood culture ideas. So we have a lot of ideas and the source to display in these ideas in the exhibition. You see, it's a tree with branches. It shows a lot of things. They can be used to make a lot of things, as small as toys, as big as buildings. I hope that we can use the idea of the completely use of wood to show my idea of the life cycle. Okay, we also introduce the traditional wood structure like in China and the Western countries. Now we also reflect upon the buildings in old Taiwan. For example, this is in the 1960s, our indigenous structure. Then the structure was developed as the Han people moved to the island, and then the hut has been developed into the skyscrapers. This building is 108 meters. It's now the highest building in the world, but by the end of this year, that will become the third. This interior and furniture development. I think there are a lot of experts here, and they will talk about the furniture. I will not go to details here. And then there is a craft. We understand that a lot of wood culture existing for a long time. Okay, conclusion. The fourth is that the application of wood culture is consistent with the current efforts to protect the environment. Wood building is to carry on the tradition and to conform our current attitude towards the natural resources. Wood structure protection is responsible actions for the forest products. That's the end of my presentation. Thank you very much.
那个陈教授的报告非常丰富多彩，让我们大开眼界。里面特别提到那个莫采用超声波焊接，我想问一下，这个现在已经到什么程度了？有没有投入商业化生产？那么最大的这个能用超声波焊接这个技术，这个最大的这个木材的构件尺寸大概是多大？谢谢。
谢谢您的问题。我想这个问题其实有人比我还在行，就是王老师哈。王老师在台湾大学森林系，他们也做了相关很多的研究哈。那我们在做古迹的保存的这个实务上面，我们也碰到这个问题。超声波现在发展，我想其实跟全世界碰到问题差不多，就是木材的腐朽的状况，我们发现没有办法靠一种技术、单一技术来判断。比如说，它如果是白蚁的，或者是它是腐菌的，其实它的破坏状况不太一样。所以超声波的东西变成只是方法的其中一种。我们发现超声波大概还要辅助做能量的检测、能量衰减的检测，才会比较准一点哈。这是第一个。那第二个，台湾好像还没有自己的超声波仪器商业化的这个发展，应该还没有，老师，应该还没有。所以现在我们用的基本上都还是国外、欧美，甚至日本的超声波的这个机器哦。那这些机器其实用起来的这个效果各自不太一样，因为这些机器最早被发展出来都是为了做木材分等用的，不是拿来测古迹用的。好，所以这个是最大的盲点，因为如果是做健康木材的木材分等的时候可以用，可是超声波要做古迹会有问题。那台湾木材这个所谓机械分等或者非破坏这个分等已经在推动了，这个王老师是主要的这个推手，主要的主持人。那我大概了解的状况是这样子，谢谢。
我补充一下，这个超声波啊，原来是在法国的这个 Tony Pitti 它是用这个摩擦的方式啊，它有一个这个产品。那后来大概是很多用超声波去加速它的那个弱化，然后把它技术啊，想要把它提升出来。我想大概是可能这样。
陈老师你好，你刚才给我们做了一个精彩的报告。那么我所关心的问题呢，我们这个结构建筑啊，应该考虑安全、持久性，是吧？那么在我们中国大陆呢，像南方地区非常潮湿，像我是来自武汉的，那么这个木结构建筑呢，这个白蚁啊很厉害，那么涉及到防腐材等等。那么你这个砖木结合在一起，那么它的成本跟我们目前这个钢筋混凝土结构的比较，有没有做过比较？因为在我们这个国内的目前的防腐材，很多欧洲的、加拿大的、美国的，大概卖到6000到8000块钱一个方。那么我们现在钢材的话，只卖到3000到4000块钱一吨。那么从这个竞争上面讲的话，它有一个可行性的问题，是吧？这个还有涉及到一个安全性的问题。所以这个问题呢，我们也是非常关心。如果我想回去，你刚才有很多的这个建筑形式，我们回去宣传的时候，人家就会问到这些问题。好，谢谢。
好的，谢谢您的提问哈。我分2方向回答哦。木材的确，其实在台湾问题也很严重。台湾的白蚁学名叫做福尔摩沙白蚁嘛，大概是这个全世界最凶的几只白蚁之一啊。那白蚁的问题跟气候的问题，我想是木材最大的挑战啊。那我们知道大概有几个方向可以思考。第一个，防蚁的处理、防虫的处理，当然会增加木材成本哈。会增加木材成本，那加上现在生态环保的要求那个本来可以处理的蛮不错的那些药剂又不能用，所以其实我想第一个要先从这个材料的选择开始，因为其实有一些原生材种它的抗蚁性比较好，那只要做基本的这个保护或者处理就行了哈。那第二个潮湿的环境其实倒不是太大的问题，是因为木材只要它是用在建筑里面，如果在同一个地区里面，它的潮湿的状态或者干燥的状态是恒定的哈，是比较稳定的，就不是突然干突然湿的那个状态之下，其实木材可以留得很久。那现在的建筑是因为我们建筑现在都还开空调嘛，所以你今天如果设计一个结构材它要么就整个要在建筑物里面，要么就整个暴露在外面，就不能把它留在那个露出来，就因为一半干的一半湿的，因为里面有空气在调节，那外面有湿度的这个问题哈，这个是一个想法。那第二个方向，我想可以提出来是，其实现在很多建筑师或者工程师，他的设计的方式就是要用设计的手法去解决这个问题。我们知道木材，比如说要做自然的通风，要做这个避水的这个功能，在一些细部的设计里面都可以做比如说我刚提到的我们的在高雄那个示范的案例我们把1层楼都放空了。我们把它做抬高，因为高雄也一样是热而且这个夏天湿度也非常高所以我们把它放空，所以那个就是标准，就是用设计的手法去解决材料的不足那第3个就是那个价钱的问题，其实木构造的造价在台湾这几年已经降了很多，之前可能是2倍吧那现在大概可以降到大概比这个钢筋混凝土大概多个3成。可以降到3成，30%就是比钢筋混凝土还要贵30%。那这个慢慢会有竞争力，因为这个是市场机制。如果这个市场大了以后，将来这个造价还要再降低。那其实最大的问题，我想，以台湾为例最大的问题还不是造价，最大的问题是那个施工的品质。因为那个工人很少人有办法照设计师去做很精确的这个施工，那这个是这个人才教育要注意的这个位置的地方。好，以上，谢谢。
那我问你好了，你就等于是你讲那个欧洲的那个桥梁啊，它是用这个保护起来，屋顶保护起来，它有没有一个这个政策定它的维修，就是经常维修的这个东西有没有什么方案呢？假如你放在那里，真的屋顶保护，你还是会有雨水的冲失嘛？它有没有规定说是对这样的这个桥梁的经常维修方面的这个政策有没有？
徐老师的问题就是桥梁部分我们看到，其实如果做了屋顶，主要是保护主要的构件了，那个就是不会有直接的雨水，但还是会有湿气等等的 那至少对铁件，因为现代的木构造都结合了一些金属的一些五金的扣件，所以主要是在保护那个铁件的那个部分，让它不要锈蚀的太快等等哈。那维护的部分，基本上以瑞士的例子，他们工程就是建筑品质的维护，他们是在法规里面有规定的，所以那个是有在做，都有计划性的做维护，都有计划性做维护。谢谢。
好，那就以这个精彩的这个节目，谢谢大家。